Cool. So what did you learn from previous program on the heaps and priority queues? Because we have covered priority queues, right? In part two. Part one was about the heap. Part two is about the adding priority queue on top of the heap. So what did you learn from that?
With priority queues, is that like it's not always first in, first out, that it's based on like whichever element has the highest importance?
Very good. That is about the property of priority queue. The question
Mhm.
is, what is the difference between heap, binary heap, and priority queue? So you told the
Um,
difference between queue data structure versus QADT
mhm.
versus priority QADT. That's perfect. Now, what is the difference between binary heap? Is binary heap a ADT, abstract data type?
No.
Okay. It is an implementation for what? Something, right? That something can
Uh,
be.
you're cutting off. I cannot hear you.
Okay. So now priority queue ADT is different from the QADT. Second question is priority queue can be implemented in how many ways? Like how, see, every abstract data type needs implementation, right?
Mhm.
So priority queue can be implemented using how many ways?
What do you mean, how many ways?
Like priority queue API is given to you. How would you write program to develop a priority queue? Let me share my screen and show you. So this is priority queue. I was speaking about this. This is an ADT of a priority queue.
Mm-hmm.
And you have insert operation, that is NQ means
Mm-hmm.
insertion,
Yeah.
DQ, and peak.
Mm-hmm.
These are the
Yeah.
three things, same as normal queue, but the
Queue. Yeah.
underlying properties do vary. Now, how would you provide body for these implementations? Sorry, these interfaces. Because these are not having body, right?
Mm-hmm.
This is just a definition. Somebody has to provide body.
Yeah.
How can we implement, like what, how many number of ways available to implement this? I would say API, application programming interface, or just to say, I would say header file. So last week, we have implemented this using what?
A template.
Yeah, template is okay, but you are missing the key underlying key thing. The key one is what?
We're using a binary heap.
Exactly. This is
Yeah.
one of the ways to implement priority queue.
Mm-hmm.
So priority queue is an abstract data type. It was defined by your architect here. And as a developer, once the architect has given us these specifications, as a developer, you have choice to implement it in many ways. One of the ways is using heap. Heap simply call heap.insert, binary
Mm-hmm.
heap dot insert, remove, and retrieve, which are providing body to the priority queue. So it
Yeah.
looks like both are same, priority queue and heap. Now the original question is, what is the difference then? Why don't I use heap itself than using a priority queue and calling it from a heap? I can directly use heap.insert, right? Why do I need enqueue?
Mm.
Why do I need priority queue API? I can simply use this one. So very important topic it is, because this is exactly what interviewer will confuse you. You would answer this. Still, it's not an interview, even in the office also. So what we write is just 3-4 lines, but what we should learn matters more. So heap, clearly about creation, insertion, and deletion of heap.
Mm.
Heap is one of the ways to create priority queue.
What are the other ways?
Say like if we need to go from Surrey to Barnaby, SFU
Mm.
campus, you can go through metro, public transportation. Heap is
Yeah.
like that. But you can still achieve the destination using uh, your own private vehicle,
Okay.
right? So
Yeah.
always your SkyTrain or any bus, it's not the way, right? You can use your own car or a bike. You can use, or even walk, but it takes a while, but you can still, that is also one of the ways. Same way, heap and priority queue are not same. Priority queue is generic. Heap is one of the ways to implement it. What other ways are available? Linked list, simple linked list is one way. Okay.
Okay.
Or even you can use normal queue using linked list. Internally, any queue can be implemented using any array or linked list.
Okay.
But plain array doesn't work. You need to have specifications. Those are already defined in heap. Similarly, you can use create a linked list and build heap properties, priority queue properties in that linked list. Okay, so I'll just give it to you to try and do that. So when anyone asks you in interview or in the real world, difference between priority queue and heap, they are not same.
Okay.
Priority queue is important. Heap is just a way to implement it. If it is not available, still you have many ways to do so. One of those ways is linked list. Okay, keep that in mind. Now, time complexity. If you use linked list versus heap, what is the time complexity? To insert element based on priority in a heap is how much time does it take inserting an element?
Oh, one, because it's always at the end.
But you need to do heapify as well, right? You need to
Oh yeah.
reconstruct the heap.
Um,
What is the time
log
complexity per
n,
log n?
because you're only making a switch, right? So
You need to do that switch multiple times, right?
so
Each time
times
you need
n
to
times
do
each element.
right each level.
Yeah.
That's-
So n log n.
Makes sense, but I, I am kind of disagree into, because you take one element, you will do the heapify operation, and once that element is over, you will go up to the one level and then do it to its parent, and then its parent, and then its parent. So it's not going to do for, we are not doing it for every element. We do it only to the parent, parent, parent. Bottom, its parent, its parent, its parent. And as part of that, it does. So in big O terms, we can still consider it n. but it's not real n.
Yeah, because it's not every
It's
single.
log n into log n only,
Okay.
because number of parents,
Yeah,
level of the
it's high.
tree. So I would say h. Again, this one is also height. So it is height into big O of, again, height. So which is bigger, height or logarithmic? Sorry, log. I would say height. Big O of h. H into big O of h. So technically, I would say just a h. H is nothing but big O of log n. Because
Mm,
the heapify has to do multiple times
mm,
like this. Until how many times?
which is
Until h number
the
of
height.
times. What is height here? Log n.
Mm,
It's just again log n times. So it's pretty beautiful recursive concept. So that's why uh, you 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 can't really say it is n number of times, because n means number of elements in that whole tree. Say like you have million elements. What is the logarithmic value of a million? It's hardly 2 power 64 or
uh,
128, right? You'll get a million for uh, 2 power 32, 64, that range. I think 32 is itself is more. So you just need to do 32 times, not million times. Heapify operation.
yeah. Is log n the same as log 2 of n?
Yes, ideally. But
Okay.
see, it's ideally log E. E is 1.8 around.
Yeah.
See, so it is closest to 2. So that's why we just, for our mouth calculations, we use 2.
Okay. Yeah,
Technically,
because
it
my
is
teacher always
E,
uses 2n. Yeah.
right? So technically, it should be E. E is 1.8999, something like that. So it is closest to 2. So in big O terms, we replace E with 2.
Okay.
Cool. So just for our number's sake, I would simply use big O of log n into height. Okay. Now the question here is, this is with heap, but if you use linked list to reconstruct the whole linked list, how much time do you need? That is where you definitely need n into log n, n into big O of n, n log n.
Because it's n elements and then switches.
And I mean, you don't need even log n. It's simply n square, n into n. Why? Every element you need to touch, and n
It's
number of
just
times
switch.
you need to do those operations whenever
Yeah.
any new element comes in. So that's the reason where heap is more optimized compared to n if you take millions, because logarithmic will take only 32, but this one takes a million itself. Okay, but you need to call out this in the interview.
Okay.
And what is the fastest area with this? Heap
Insertion.
peak operation. Peak
Oh,
operation. If you want to search for any element, search for the highest element, maximum. This is just order of n. You will get it from the root node. But in the linked
from the
list,
root, yeah.
if you need to get the highest value, i- still
You
you
have to
need to
look at all the
go.
elements.
Yeah. I mean, if you keep that based on the priority at the head node, it will conflict based on your arrangement. It can be big O one n or big O of n based on your arrangement. Usually, you can prefer to keep that min or max element in the head node and then use the same. However, heap main advantage is this one. Pick the root and or delete or pick whatever. This is the simplest one. All right. But deletion of a node in linked list requires again n operations in the heap, but the deletion in the heap will hardly take you big O of 1, but the heapify will again take you big O of log h or log n.
Mm.
But when it comes to the linked list approach, search will take you n number of comparisons,
Alone.
and then the deletion is just a single operation.
Yeah.
Still, if you take in the big O of terms, always heap is winner compared to linked list. That's why in the books or in your examination, this is not covered much. This is just a theory, the linked list approach. But the heap using array or a vector is a proven approach for priority queues. Any doubts on it?
No.
So writing 3 lines is easy in the interview, 3 or 4 lines, but explaining this matters a lot. All right, I'm going to stop for now, and then we will continue in another video about many more. Let me stop. So this is going to create as one video, and I will restart a recording and give you an interview problem.